Okay, now we're going to look at a practical example using similar triangles. And people actually use this to measure heights where they can't actually measure it because it's too tall or whatever. And it does work pretty accurately. We have a lady here that's standing and she's 5'4" and her shadow is 40 inches long. We also have a flagpole and the shadow is 50 feet long. Okay, so we want to know how tall this flagpole is. Basically what we do is we'd create two similar triangles. I'm going to show you what that looks like on the next page. You can probably guess which one it's going to be here, but it's going to look something like this. So the flagpole and the woman form the right angle for the first right triangle, and the sun's rays hit the flagpole and the woman at the same angle, so therefore we know we're going to have angle-angle similarity. Again, we know that this angle and this angle are going to be equal because the sun's coming down basically at the same rate. So what we need to do here is, if you notice, we've got 5 feet 4 inches and 40 inches, and then we've got feet here and feet here. So we need to convert this to inches or convert this to feet. Probably be easier to convert this to inches. So your fraction is going to look, or I'm sorry, your proportion is going to look something like this. So again, 5 feet 4 inches is 64 inches. So we would take the unknown for the height of the flagpole divided by 64 inches, and then we'd take the shadow here at 50 feet and 40 inches. As long as you have feet to feet and inches to inches, you're okay. You could have also written this as feet over feet and inches over inches, and it would have worked if we had exchanged the means here. But this is the way we did it. We did the height to the height and then the shadow to the shadow. So we cross multiply here. We get 40x equals 64 times 50. We divide both sides by 40. We get x equals 80. So that means that the height of the flagpole is 80 feet. So we've got 80 for the height and 50 for the shadow. Okay? We're going to do another problem like this just to see how it is. Remember again, we had this and this for the flagpole, where we found out this was 80 feet and this was 50 feet. Okay, we have a child who's 58 inches tall. We want to know how long the shadow is. So again, what we can do is we can say, here's the child, and there's their shadow. And since this angle, which is the angle of the sun to the shadow, should be equal to this one, and these are right angles right here, and again this is 58 inches, we can then say that 80 over 58 will match with, we'll call this y, I guess. We'll say y. Ooh, let's see. Sorry. If we do 80 over 58, we have to do 50 over y. So it's big to small, big to small. Okay? We get 80y is equal to 58 times 50. I'm going to divide both sides by 80. Don't have a calculator handy, so we're going to divide those two, and then this and this are both divisible by 2 for sure. So we get a 4 there, and we get a 29 here. And I think that's right. Divide by 2 is 29. Yep. So if we calculate that out, y is going to be equal to 29 times 5 is 5, carry the 4. 145 over 4. And that equals 3, 6, 36.25 inches. Okay? There you go. And then here's another one where it says you're standing in the backyard, you measure the lengths of the shadows cast by both you and a tree, write a proportion showing how you could find the height of the tree. It would look similar to the ones we just did. We'd say tree height over your height, length of shadow for the tree over length of your shadow. Okay? And I believe that's it. Yep. Thanks.